So hello students and welcome again to today's lesson. My name is Mr. Meshak Ngige and welcome to eMaths with Ngige. So kindly remember to subscribe, share and also comment as we learn together through our lessons. So today we're going to look at something new, but we're going to check it as we do some Knec revision here, and that is power series, alright? And specifically here we're going to be checking, we have a number of power series, but now we're going to be checking two, that is the Maclaurins theorem and also the Taylor's theorem. So now let us state the Maclaurins theorem and the Taylor's theorem and see some few questions from Knec past papers and see how the approach is done. So kindly keep posted and let us learn together. So therefore, let's check. First of all, we start with the Maclaurins theorem. So we say the Maclaurins theorem is given by the expansion, given by in this form. So we are saying the series for a certain function which is fx will be given by a function where you shall replace your x being 0. So your function when your x is 0, right? So then we have our x, then we have the first derivative, again your x being 0, then you have x squared, then your second derivative, this means prime, okay? We have a single prime which means the first derivative. Double prime means you differentiate twice, right? Third derivative also is given by prime 3. Then we shall be replacing our value of x being 0 in our cases here, alright? So you're saying the function when your x is 0, then x, the first derivative, our f naught. Then you have x squared, second derivative 2 factorial. Then you have x cubed. Now this cube, this one is cubed here, right? Is cubed, then third derivative, then 3 factorial, and so on and so forth. So you can also guess what the other terms are going to be, because you shall have x to the power 4, the fourth derivative, then over 4 factorial. Now here we have this term, the factorials are in increasing order, but we always start our factorial with 0. Now in our case here, it means the first term is over 0 factorial, the second term is over 1 factorial. Then 2 factorial, 3, 4, 5, 6, and so on and so forth. But now, if you can check from your calculator, 0 factorial is 1, and also 1 factorial is what? Is also 1. That is why, if you divide a number by 1, we don't necessarily need to write the 1, alright? But this one is over 0 factorial, over 1 factorial, over 2 factorial, over 3 factorial, and so on and so forth. So, it goes on and on. So you can see, our power and our derivative are always of the same order, because we have second to power 2 derivative twice, power 3 then third derivative, and so on. And also we have the factorial, which is also the same with whatever we have here. So now let's check a question here. We have expand sin x using Maclaurins theorem as far as x to the power 4, right? So therefore the solution. So the solution, so we shall have our f of x. So what is our function? Our function is sin what? Sin of x. So we shall be having two things to do at the same time. So we shall be differentiating our function. Then we shall be, as we differentiate, we replace our value of x being 0, right? So now what is our f naught? What is our f naught? So when you replace 0, okay? When you replace 0, what do you have? The sign of 0 gives you what? So where we have an x, you put a 0. So sign of 0 gives you what? Gives you 0. Then you go, we differentiate the sine function once. When you differentiate sine, you get what? You get cosine of x. Then again, f prime 0. So where we have an x, put 0. So what is the sine of 0? It's what? Cos of 0 is what? It's 1. Then differentiate twice x. When you differentiate cos, you get the negative of what? Negative of sine. So negative of sine x. But we know f double prime of 0, which will give us what? When you put a 0 here, we'll have sine of 0. Sine of 0 will be 0. And if you multiply with the negative, you see 0. So we have 0. Then you can have triple x. When you differentiate sine, you get cos, but this negative remains. Are you together? So we shall have negative, which is just here. When you differentiate sine, you get positive of cos. So it just remains cos of x. Then f double prime 0. Now it is triple prime, sorry. So we shall have So replacing value here 0, we shall have cos of 0 will be 1, but you have a negative. So what will be a value? A value will be negative of 1. So we can continue on and on with this series. So this one is triple prime. Okay, let's go up to the fifth, let's say. So you can go fourth. So 4 over x. Differentiating cosine of x, we get negative of sine. So we shall have negative. Now differentiating cos is negative sine. So negative of sine of x. So negative gives you what? Positive of sine x. Then f, then to the fourth, then you replace with 0. So where you have this, now you can see we already will come back here. So what will we have as a value? So we should have 0. Then you can have maybe the last one, that should be the fifth. So we shall go, this one will give us. Now differentiating sine, you get cosine of x, which are 2 power 5, 0, which will give us what? Will give us 1. So, but remember, we were supposed to go up to the fourth term. So basically, we can just have that. Now let us now write our series. So therefore, the expansion, so what is our fx here? Our fx is the function that you have, which is sine of what? Sine of x. So the expansion for sine of x will be given by f naught, which what is our f naught value? It was what? It was 0. So we have 0, then we have plus, then we have x, right? The first derivative gives us 1, okay? So we have 1 over 1 factorial, which is just means the same, plus x squared. Then x squared, second derivative gives us what? Gives us 0 over 2 factorial. Okay, then we have x cubed. What is our value? Negative 1. Then we have this one will be over what? Over 3 factorial. It's supposed to go up to 4. So we can have the last one. We can have the last one, which is given by x to the power 4. What is our value to the power 4? Derivative to the power 4 gives us what? 0. So we have 0 there. Then over 4 for factorial. So we have equals to, now here we have a 0, x times 1 gives us x. Here we have a 0, 0 times anything is just 0. Then we have negative of what? Negative of x cubed. So we shall have negative x cubed because you have a negative here. Then we shall have 3 factorial. Then we have plus what? Plus 0. Now, you notice something, as you continue with the expansion of this, so we were to go further. We were to go up to this term. Let's say this is the fourth. If we were to go to the fifth, our value will be this term here. So if I was to expand this, let me go a step further. So we shall have x to the power 5, then you have 1, right? Then you have 5 factorial. So if I was to include this term here, this term will be 0, alright? Then let's include this. Will be plus x to the power 5, then over what? Over 5 factorial. So there is something you can note from this. We have x, then we have an odd number here, an odd power, then an odd factorial. Then we have an odd power, an odd factorial. So you can always give a guess. So give a guess, what can we have here? What will be our next term? Will be what? It will be plus x to the power 7 over 7 factorial. No, now notice something, sorry for that, it will be a negative because our term will be changing from positive to negative. The reason being because of the cosine function. It will be alternating from a positive to a negative. So we have a positive, negative, positive. So the next one here will have x to the power 7 over 7 factorial. Then plus, what is the next odd number? 9. So x to the power 9 over 9 factorial. Then the next number minus x to the power 11 over 11 factorial. And this will give you the expansion for the sine function. So with this, can you give a try to work out the expansion for the cosine function as we check the next question. So we check another question from the June-July 2020 series. And the question says, find the first term or the first three non-zero terms in the Maclaurins series. Expansion of fx equals to sine squared of x. So that is the first part. Then the second part, you use the answer that you get in the first place, in the first part of the question. to evaluate the second part. Now, this is simple, it can be done, so we check the solution. Now, what is our function? Our function is f of x. And what is our function? This is sine squared of x. Now, when you're expanding such functions, you need to remember one thing. That sine of x can be written as, right? This part here can also be written as, sine of x. You can put this square, what? You can put that square outside. Okay? So you can put it outside. Now you can find now your f naught. So replacing where you have an x, you put what? You put 0, right? So if you put 0 here, you have sine of 0, and sine of 0 is 0. You square it, it still becomes what? Still becomes 0. Now let's come to the second part. First derivative of our function x will be given by. Now this type of function is solved by something we call function of a function, that is the chain rule. But I'll show you a very simple way that you do this. But basically it's just the chain rule, where you let the function that is inside here to be u, then you find your du dx, and you can call this function another name. Then you get you can get your dy du and du dx, right? But now simply you can do this. You can drop the power, right? You remember you can remember how we used to just differentiate function. That is polynomials. You drop the power, reduce the power by 1, then differentiate the function that is inside. Right, together. So we have this function here. So we are saying drop the power. So what is our power? This is just chain to chain rule, but just in a simple way. We are saying drop the power, which is 2. Are you together? Then rewrite the function. Then reduce the power by 1. So this is squared. So when you reduce it by 1, it becomes what? 2 power 1. Then multiply by the derivative of the function inside. Okay, so what is the derivative of the sine function? It gives us the cosine function. So it gives us cosine of x. So this one gives you 2 sine of x and cosine of what? Cosine of x. Now. So we have this. We have this part here. So you can still again replace. You can replace this with a value. What do we know from trigonometry? We know something about double angles. Right? We know something about double angles. That, let me just note it down here, that sine of 2a is the same as 2 sine of a cosine of what? Cosine of a. And what do you notice here from this function here? That this function can be rewritten in this form. So this part here is just the same here, but our variable here is not now. We have what? We have an x. Right, together. So we can change the whole of this function to become this function. And this will be very efficient, especially when we shall be replacing our values. When we shall be replacing our values, we shall have a very easy time coming in a differentiation. So we're saying, therefore, this function will be replaced by, so since we have this, hence, so this is from trigonometry, hence, sorry, f of x will be given by, so replacing the whole of this with a function of this side, just what? Sine of 2 what? Sine of 2x. Right, together. Then now find our first derivative again. We'll replace it with equals to 0. So replacing 0 here, we still have what? Still have 0 as our answer. Now let's now differentiate our function. Let's get now the second derivative. So the second derivative here will be given by remove the term outside, so you shall have 2. When you differentiate sine, you get what? Cosine. So cosine of what? Cosine of 2x. Then replace that now 0 again. Cosine of 0, you have 2 times 0, which is just be 0. But now, what do we have here? 2. This part here becomes 1. Right? This part here becomes 1. Then times 2, which gives us what? Gives us 2. Then triple prime x, we shall have, now remove the power again, so we shall have 4, right? Now when you differentiate cosine, you get the negative of what? Negative of sine. So this negative we shall put it here, right? Then we shall have sine of 2 what? 2x, then 3, then 0. The aspect that we have a sign here, when you replace a 0 here, just becomes what? Just becomes 0. Then you have 2 power 4 of x be given by, so again remove the power outside, we shall have negative of 8. When you differentiate sign, you get cosine, right? So we shall still have positive of cos of 2x. So remember here we have just removed the 2 outside, we have negative 8. And because we differentiate sign, we get a positive of cos, then the negative remains. Okay? Then that one, 4, then we replace with 0. We shall have what? This term here, when you replace with a 0, in this position here, we have 2 times 0, which is 0. Then the cosine of 0 gives you 1. Okay? So 1 times negative 8 gives you negative of what? Gives you negative of 8. Then you have 2 power 5 x. We shall have, again, remove the constant outside, so we shall have negative of 16. Now, when you differentiate cosine, you get negative of sine. Are we together? You get the negative of sine, and you have another negative here. So you remove this negative here, so it becomes positive. Then we shall have sine of 2x, then 2 power 5, which are 0. Then the aspect that we have a sign here, what will we have as our value? Our value will still be 0. Then, so we go to the 6th. So x. Now differentiating this one again. When you differentiate sine, you get a positive of cos. So basically, we shall just have the constant going outside. So we shall have 32 cosine of what? Of 2x. Then we have the 6th. Then we replace that with 0. Now the cosine of 0 gives us 0 times gives us 1 times 32 gives us 32. Remember, we just trying to get what? The 3 non-zero terms, and you can see you already have one term which is non-zero, another term non-zero, another term which is non-zero. So we can now write the series for this. So therefore, the sine squared, the series for sine squared of x will be given by. So we say it is the first. We have our first term, which was here, your f naught. So your f naught is 0 plus x. Your first derivative is still 0. So 0, then over 0 over 1 factorial. Sorry. So that will remain with that. Then plus x squared. Second derivative gives us 2. Okay. Then all over 2 factorial plus x cubed. What is our third derivative? 0. Then we have over 3 factorial. Then plus we have x to power 4. Then we have, what is the fourth derivative? Negative 8. Okay. Then all over 4 factorial. Okay. Then we go to the next one. We have x to power 5. What is our fifth derivative? 0. All over 5 factorial. Then plus, we have plus x to power 6. I think that will be our last term. Then you have 32. Then you have all over what? All over 6 factorial. So therefore, we shall remove the zeros there, so we shall have sine of square x, which will give us. So this term will be 0. This term will be 0. So we shall have 2. Then we shall have x squared all over 2 factorial, that will be the first term. This term here will be 0. Then we shall have this term, which will have negative 8. So minus 8 all over 4 factorial. Okay, so you can say 4 factorial x squared. Okay, then this term will be 0. Then you have this term which will be 36. So positive, yeah? 32, sorry, x to power 6 all over 6 factorial. So just writing what we have there. So we have this. Now let me simplify now this further. So we shall have now 2 factorial means, now let's go procedurally. So square of x equals 2. Now we have 2, then we put that on there. Then 2 factorial means 2 times 1, which is 2. then you have minus, so we shall have, let's say, negative x, negative 8 there. Then 4 factorial means 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2 is 20, 24. Okay, then you have plus, then you have a constant is 36 here. Then x to the power 6, then all over 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which will give you, from your calculator you can get it directly, which I believe will give you 720. Now simplifying this further, these 2 and these 2 cancels, we have what? X squared. Now a number that can enter into 8 and also 24, which will be 8. 8 goes into 8 once, so minus 1, then into 24 how many times? 3. Then you have x to the power 4, then plus. Now this is 32, sorry, this is 32. So therefore, which number can enter into, so you can have a number like, let's say 16. 16 will enter into 32 twice, and will enter into 720 45 times, then you have x to the power 6. So therefore, when you expand the sine squared of x, its expansion will be given by this. That is up to the 6th term, not the 7th term by the end of the day. Alright? So we shall have that. So this is the first part of solving the expansion for that. Now we can use this to solve now the second part, which is to solve the integral from 0 to 1 of sine squared x, now over the root of x dx. Now this is simple because we shall have, now the second part we shall have the integral of 0 up to 1. Now, what is the expansion of sine squared of x? We shall use this expansion here. So we shall have x squared minus 1 over 3 x to the power 4, then plus 2 all over 45, then x to the power 6. Okay, then all over, we can derive the root of x as a fraction, which will be what? X to the power of what? X to the power of a half, then dx. So you're going to simplify this further. When you have a term and the power is at the denominator, you can bring it back, bring it to the numerator, but you negate the power. So this one again being simplified further, we shall have 0 to 1. Now we shall have x squared minus 1 over 3 x to the power 4 plus, okay, plus 2 over 45 x to the power 6. Now into bracket. Now our x will be multiplied here, but now we shall have it as a negative of what? The negative of that. Before we even integrate, we simplify this further by the laws of indices. So this is just a few applications of our mathematical knowledge. So this x will multiply every term inside here. But notice something here, an x appears in each and every term. Are you together? An x appears in each and every term. Now, we know one thing, if you multiply x to the power 2 times x to the power negative a half, when you multiply numbers with the same base but different powers, what do you do to the powers? You add the powers. So that means if I multiply x to the power 2 multiplied by x to the power half, I shall add 2 plus negative a half. Right? So basically, if I multiply this and this, I'll just get x. 2 plus negative a half will just be 2 minus a half, that is 1.5, which is the same as 3 over what? 3 over 2. Then minus, the constant remains to be a constant. Then you have x. Then 4, we have minus 4 plus minus a half. So this multiplied by this will be 4 plus minus a half, which will be 3.5, which is just the same as what? That will be 7 over 2, right? Then plus 2 all over 45. Then you have x. Now 6 plus minus a half, which will give you 5.5, which is the same as what? 11 over 2. Right, together. So we shall have that. Then d what? dx. So integrating from now integrating from 0 to 1, so we shall just integrate in this case, so we will not have that. So integrating we shall have our bracket here. Now integrating this will have x, increase this by 1, will give you 5 over 2, then divide by 5 over 2. Then the next one will be minus, a third is a number here, so just a constant, Then increase this one by 1, it will be 7 over 2. Now it will be 9, right? 9 over 2. Then divide by 9 over 2. Then plus 2 all over 45 x. Increase this one by 1 again. It becomes what? I think it will become 13 over 2. Then divide by 13 over 2. Then your limits, we run from 0 to what? We run from 0 to 1. Let me use this space here. So therefore, this term here, when you divide by a fraction, you can reciprocate these fractions all together. You can just flip them as a reciprocal so that you can multiply with whatever we have here. So this will be the same as saying. So this part, just have another line there, which allow 2 all over 5 x to the power 5 over 2. Right, 5 over 2, then minus. So you reciprocate this, you shall have 2, right? Then this and this will multiply together, which will give 27. Then x to the power 9 over 2. Then plus. You flip this, so 2 and 2 will multiply together. We'll have 4 all over. What is 45 times 13? So 4, 5 times 13 will give us 585. 585. Then x for 13 all over 2. So all these from 0 to 1. So basically what you're saying here is replace now your first with 1, then your lower limit. The upper limit is 1, the lower limit is 0. So now replacing your term, x to any power just becomes what? Just 1. Okay, 1 to any power is just 1. So therefore, replacing the upper limit, we shall have 2 over 5 minus 2 over 27 plus 4 over 585. Okay, yes, 585, then into bracket. So that is the replacing the upper limit. Then replacing the lower limit. When you put an x being 0 here, this becomes 0, this becomes 0, this becomes 0, so 1 is 0. So therefore we shall have our solution as 2 over 5, alright, minus 2 over 27, okay, 2 over 27, then you add 4 all over 585. You shall have your answer as 0. This will be given by 0.33. 3 decimal places. I believe that was the answer. Let me just write this first. 276. So in 3 decimal places it will be 0.33. So check this number. So we shall round it off here. So we shall have the answer as 0.333.